Hello everyone, my name is Chris Edwards and today we're going to write a SQL query. Our problem today covers some common SQL functionality related to aggregations. The Avian Adventurers Club is a group of nature enthusiasts who frequently go bird watching together. In order to spice things up and to motivate some of the newer members, the club leaders decide to award a small prize to anyone who spots at least 3 different species of bird during the next club outing. In order to track progress toward this goal, every time a club member spots a bird, they use an app to record the species of bird and the time of the sighting in a database table, bird sightings, with the following structure. We need to write a SQL query that returns the winners of this little bird-watching game. Specifically, the query should return the names of all club members who saw at least 3 different species of bird, along with the total number of species they saw. A couple additional notes here. If someone saw the same species of bird multiple times that day, that will be represented by multiple rows with the same club member name and species values, but different sighting timestamps. You can see an example of that with Ava here, who saw the unspeckled poffle twice on that day. Also, the results should be returned sorted by species count from greatest to least, and to get the most benefit from this exercise, you should try to solve this with just a single select statement, no CTEs or subqueries. And that's all the setup for today. If you want to have a crack at solving this problem yourself, there are links in the video description to this full problem statement and instructions on how to replicate this coding environment on your local machine. Feel free to pause the video now and come back later for a solution walkthrough coming right up. All right, welcome back everyone. We will now take a look at a possible solution to this problem. As with any problem, the first thing you should do is try to break it down into more manageable components. We need to create a report with the names of each club member who saw at least 3 different bird species, along with the number of species each of them saw. I'm going to set aside the at least 3 different species part for now. We'll come back to that later. To start with, I want to focus just on what columns need to be in the report and how to populate them with the correct data. We need 2 columns in our report, club member name and let's call it species count. So let's get that much down in a stub query right here so we can build on it. We're getting club member name, and then we have a placeholder column for species count. And we get club member name easily enough just straight from our bird sightings table. That's already provided for us. But what about species count? For this column, we need the number of bird species that each person saw. And the number of bird species is an aggregate metric. The phrase each person implies an aggregation at the grain of club member name. Translated to SQL, that means we need to invoke some aggregate function while grouping by club member name. So let's add that to our query sketch here. We've now grouping by club member name. We have some placeholder aggregate function here. All right, so next up, we need to decide what aggregate function to use. We are trying to calculate the number of bird species seen per club member. In other words, we need to count the number of species. So we probably want to use the count function and pass it the species column, like so. And since this is now a syntactically correct runnable query, let's run it and see where we are. All right, so the good news is we now have a report at the club member grain and a numeric column for species count. The bad news is the counts are wrong. If we look back at our source data here, we can see that, for example, Ava had 3 total sightings, but she actually only saw 2 different species of bird. She saw the unspeckled poffle and the fruit loon. Our current query here has Ava at 3. And that's because it is counting the number of sightings each person had, not the number of species. we have a situation here where the grain of our source data is different from the grain that we want to base our count on. Our source data is at the sighting grain, but we want a count of bird species, regardless of how many times each person saw them. One way to resolve this would be to split up our query into multiple parts using a CTE or subquery. And in the first step, we could use a select distinct query to get our source table to the grain that we need, and then our count function will return the correct results. However, thanks to some nice syntax that I believe is very widely supported across most, if not all, database systems, we don't need to do all that. We can just put a distinct within our count function itself, like so. And now we truly are counting the number of species each person saw, the number of distinct species, instead of the number of sightings that they had. And if we run this, we can see that our counts are now what we wanted. And specifically, the counts for James and Anna here now exactly match our expected output on the left. So we're almost there. The only thing left is to finally account for that condition in the problem statement to only list club members who saw at least 3 different species of bird. Well, we have calculated species count for each club member. Why don't we just put that in a where clause and call it a day? Got where count distinct species is greater than or equal to 3. Let's run that. And, oh no, we get an error. Aggregate functions are not allowed in where. Similar to our previous situation with counting distinct values, this problem can be surmounted by splitting the query up into multiple stages, calculating the species counts in a CTE or subquery, and then filtering on that computed column in a subsequent query. But, yet again, we don't have to do all that thanks to some nice, pretty universally supported syntax called a having clause. And I'll show you what that looks like first, and then I'll explain it a bit. So to start off, this query using the having clause, this works. We are done. This returns our expected output. This produces precisely the data that is listed in our expected output on the left here. But I want to take a moment and explain why this worked, but the version we had just tried with the where clause didn't work. There's really very little difference between where and having, except that having allows you to filter on the results of aggregations, and where does not. And the reason for that has to do with the under-the-hood execution of SQL queries. When you submit a SQL query to your database, internally it parses that SQL query into several steps that always execute in a specific order. And this is that order. First, it parses the from and join clauses to figure out what tables are involved in your query. Next, it uses any where conditions to filter out rows from those tables. After that, it parses any group by clauses and performs aggregations. And now this is the key reason why we can't use a where clause to filter on the result of an aggregation. At the time the database is executing the where clause, it hasn't done the aggregation yet. Group by comes after. The data is not yet available to filter on. And that is where the having clause comes in. As you can see in the execution order, having is right after group by, and therefore the results of aggregation are available for filtering. Now you might ask, what's the point of SQL using both where and having? Why not just have one way to filter that always works in every situation? Well, I can't speak to the exact history of the development of the SQL language, but I can say from a practical perspective, it makes sense to have the option to filter before aggregation or after aggregation. You need an after aggregation option if you want to be able to filter on aggregates at all. But having a before aggregation option is also very useful from a performance perspective at least, since it lets you filter out unneeded data before performing a potentially expensive aggregation. So that's the SQL execution order, or at least as much of it as you need to know to understand the difference between where and having. As an aside, you may notice that select is pretty far down the list after where, group by, and having. This is the reason I had to write having count distinct species greater or equal to 3 instead of simply having species count greater than or equal to 3. Because this select clause has not run yet, the column alias we've defined here, species count, is not yet known to the query processor at the time we are running our having logic. So we can't use the nice friendly name species count. We have to repeat the full calculation here. Not all databases have this restriction. Some, like Snowflake, for example, papers this over with some extra processing on the back end, so it actually does let you use the aliases in having and similar clauses. But the classic SQL execution order that is still followed strictly by many databases, including Postgres, does not allow you to do that. You may also notice here that order by comes after select in the execution order, and that is why, in contrast to everything I just said about having, we can use aliases like species count here in the order by clause because it is parsed after select, and therefore those aliases are known and available. Just a few more fun tidbits about SQL execution order. All right, well, that's it for this video. Thank you all for watching. If you have any further questions about this problem, or if you think of a different approach to the solution that I may not have considered, please let me know in the comments, and be sure to subscribe for more SQL query writing content in the future. Until next time, happy querying.